In the pursuit of sustainable energy, hydrogen combustion engines are showing promise as an alternative. These engines provide major environmental advantages, such as zero carbon emissions and decreased pollutants, by using hydrogen as a fuel source. Hydrogen combustion engines may be essential to the shift to environmentally friendly transportation as technology develops, especially for heavy-duty applications and in locations with pre-existing fuel infrastructure. In this video, we will go through 7 key points that illustrate their potential for a cleaner energy future. Zero carbon emissions. Because hydrogen combustion engines can run without releasing carbon dioxide, a key greenhouse gas that greatly contributes to climate change and global warming, they are at the forefront of clean energy technology. During operation, CO2 emissions are essentially eliminated because hydrogen only produces water vapor as a consequence of its reaction with airborne oxygen. This trait is especially important in the transportation industry, which, according to the Intergovernmental Panel on Climate Change, accounts for around 14% of worldwide greenhouse gas emissions. Although trace amounts of NOx are produced by H2ICE, improvements in emission control technology, such as better combustion chamber designs and catalytic converters, are aimed at reducing these emissions. Rapid refueling. One of the most alluring features of hydrogen combustion engines is their quick refueling ability, especially for applications that need high availability and little downtime. It usually only takes 3 to 5 minutes to refuel a hydrogen vehicle, which is about the same amount of time as refueling a traditional gasoline or diesel vehicle. For commercial applications where operational efficiency is crucial, including buses, trucks, and emergency response vehicles, this rapid turnaround is extremely advantageous. This quick recharging capability can greatly increase productivity and save operating costs in industries like logistics and public transit, where vehicles are anticipated to be on the road for extended periods of time. High energy density. One important element that increases hydrogen's attractiveness as a fuel source for a variety of uses, especially heavy-duty transportation, is its high energy density. For applications where weight and space are important factors, hydrogen is an effective choice because it has almost 3 times the energy per kilogram compared to diesel fuel. Because of its high energy density, hydrogen-powered cars may go farther between charges without requiring bulky or unwieldy fuel storage devices. In contrast to BEVs, which may need more frequent recharging because of their lower energy density, a hydrogen truck can travel several hundred miles on a single tank of hydrogen, potentially surpassing the range of many battery electric vehicles. Additionally, because manufacturers do not have to make room for the bulky battery packs needed for BEVs, this feature allows them to create lighter vehicles. Utilization of existing infrastructure. The transition to hydrogen combustion engines can be significantly accelerated by leveraging existing fuel infrastructure that many regions already have in place. Established networks for distributing traditional fuels like gasoline and diesel can be adapted for hydrogen use with relative ease. This includes retrofitting existing gas stations with hydrogen pumps or utilizing existing pipelines for transportation and distribution of hydrogen fuel. Such adaptability minimizes the need for extensive new investments in infrastructure compared to battery electric vehicles, which require new charging stations, often necessitating upgrades to electrical grids to support increased demand from widespread EV adoption. Utilizing the fuel infrastructure that many areas already have in place can greatly speed up the switch to hydrogen combustion engines. Environmental benefits. Compared to conventional fossil fuel engines, hydrogen combustion engines produce fewer harmful pollutants during operation, which helps to improve overall air quality in addition to eliminating CO2 emissions. Hydrogen combustion improves public health outcomes in metropolitan settings with air pollution because it produces very little sulfur compounds and particulate matter, 2 known causes of respiratory illnesses and environmental deterioration. Environmental agencies have found that switching from traditional ICEs to cleaner alternatives like H2ICE might significantly reduce smog generation and associated health problems, including cardiovascular illnesses and asthma in urban populations. Adopting cleaner technology like H2ICE becomes more appealing from both an environmental and public health aspect as cities work to fulfill the strict air quality criteria set by regulatory bodies and enhance the livability of inhabitants. Potential for renewable hydrogen production. In the larger framework of sustainable energy systems, the production of hydrogen from renewable sources offers an intriguing potential. There are a number of sustainable ways to produce hydrogen, including electrolysis, which separates water into its component elements of hydrogen and oxygen using renewable electricity from solar or wind power. In contrast to gray hydrogen made from fossil fuels using steam methane reforming, this approach produces green hydrogen, which has a lower carbon footprint. One of the main issues with renewable energy is intermittency, which is effectively addressed by combining renewable energy with hydrogen production processes to create a closed-loop system that not only produces a clean fuel source, but also aids in energy supply stabilization by storing excess renewable energy during times of high generation capacity or low demand. For example, excess solar power can be used for electrolysis rather than being reduced or wasted during peak solar generating hours when energy consumption may be low. Because of its adaptability, hydrogen is positioned as a key component of global energy policies that prioritize sustainability and promote decarbonization initiatives in a variety of industries, including heating, transportation, and industry. Advancements in technology, continuous research and development is necessary to improve hydrogen combustion engines' environmental performance and efficiency. In addition to reducing NOx emissions, which are a problem with conventional combustion processes, innovations like advanced catalytic converters are being investigated to increase engine efficiency overall by capturing pollutants before they are released into the atmosphere through improved exhaust treatment systems. Additionally, efforts are being made to improve engine design, especially the geometry of the combustion chambers, in order to increase fuel economy and reduce waste products produced during operation. More widespread adoption of H2ICE across a range of sectors, including transportation logistics, industrial applications, power generation, etc., is anticipated as these technologies advance through cooperative efforts among academia, industry stakeholders, including automakers and government agencies focused on clean technology innovation funding programs. In summary, hydrogen combustion engines present a promising pathway towards cleaner energy solutions, particularly in sectors where rapid refueling and high energy density are critical. If you liked our video, please hit the like button and subscribe to our YouTube channel.